Here we have a two-way table, including information about girls and boys and the various year groups at a school. So the years are in the columns, telling us how many boys and how many girls in each year group, and in the rows are the number of girls and boys. We have a total of 1,030 pupils in the school. If we want a 10% sample, that means we're going to need 10% of 1,030, which is 103 pupils in our sample. Let's consider first of all stratifying by the number of girls and the number of boys. In other words, we're stratifying by gender. What do we even mean by this? We could be asking a question which is likely to be answered differently by girls and boys, and therefore we want to ensure that we get a proportionate number of each in our sample. So let's look at this. We can see that there are 513 girls. 10% of this is 51.3. There are 517 boys, so that's 51.7 if we take 10%. Clearly we can't have 0.3 of a girl or 0.7 of a boy, so we need to round. If we took 51 girls in the sample and 52 boys in the sample, that would give us a sample of 103, and the number of girls and the number of boys would be proportionate to the total number of girls and boys in the school. Let's suppose instead that the question we're asking is more likely to be answered differently according to the age of the child rather than their gender. In that case, we might want to stratify by year group. So let's consider stratifying by year. If we look at year 7, we have 210 pupils. 10% of this is 21. In year 8, 10% of 209 is 20.9. In year 9, 10% of 211 is 21.1. 10% of 200 is 20, and once again 10% of 200 is 20. If we now round these, so this one is 21 and this one is 21, we can see that we get our sample of 103, and we also get proportionate amounts in each year group. Let's suppose that the question we intend to ask might be affected both by the gender of the person we're asking and by their age. In that case, by taking the individual numbers, we can stratify our sample both by gender and by the year group. We need to get proportionate amounts from each year group. So let's look at girls in year 7. 10% of 110 is 11. For boys in year 7, 10% of 100 is 10. Now consider girls in Year 8. 10% of 103 is 10.3. For boys in Year 8, 10% of 106 is 10.6. Girls in Year 9, we're going to get 9.8. For boys in Year 9, we're going to get 10.3. For girls in Year 10, 10% of 100 is 10, and for boys in Year 10, 10% of 100 is 10. We then want 10% of 102, which is 10.2. And 10% of 98 is 9.8. We need to get a sample of 103, and we can't have 0.3 of a girl. We need to do some rounding, but the rounding is not always an exact science with these things. If we rounded all of the things that need rounding to the closest whole number, we'd find our sample would be the wrong size. We might decide to do this, or we might decide to keep the sample at 103 and round a little differently. For example, the 10.6 here we might make 11. The 9.8 we'd make 10. This 9.8 10 as well, and the 10.2 here also 10. With the two 10.3s, if we made them both 10, we wouldn't have enough pupils in the sample. We'd only have 102. That's one possible way of doing it. 102 is close to 10%. But if we want to keep it as 103, we could make one of these 11 and the other 10. It could have been chosen the other way round too. Once we have these groups, we find the pupils we want from the groups by performing a random sample in each of the groups.